All right, I want to talk a bit now about flash memory, sometimes called solid-state disks. Or rather, flash memory is usually combined together into disk drives called solid-state disks, and that's how it's packaged and sold, especially for database use. So the current generation in 2018 of flash technology is called NAND flash, and it has some unusual properties that you need to be aware of. It allows very fine-grained reads, so you can read pretty small amounts of data, 4 to 8K at a time. So you can point to a location on the flash disk and read as little as 4K. But writes actually are bigger. Writes are coarse-grained. You read in units of 1 to 2 megabytes. Okay, and this complicates life a bit for the flash disk. Another thing you need to know about flash disks is that for a given cell, a given memory cell on the flash disk, after 2,000 or 3,000 erasures, if you erase that cell 2,000 or 3,000 times, the cell usually will fail. And so we don't want to do writes to the same location in these disks. We don't want to have hotspots on the disk where all the writes go, which means that if you have data that is frequently written, you need to move it around on the flash disk. This is called wear leveling, because we want to level out how much we wear down these cells. Now, all this is taken care of for you under the covers by the controller of the SSD. So we're not going to write this software in the database system. This is firmware in the SSD. What we do need to know is how it affects our performance. So a write, don't forget, even if you want to write just a little bit, let's say 4K, you're going to end up writing a full 2 megabytes, okay? And that write may require reading the old version of that data and writing it somewhere else. So this is called write amplification. We wanted to write a small thing. We ended up writing a big thing and possibly doing a read and a write to reorganize it as well. Okay, so flash drives are pretty expensive to write, relatively speaking to how expensive they are to read. Bottom line, read on a flash disk is fast and predictable. Single reads are access time of something like 0.03 milliseconds, so very fast. And you can pile those up then to get random reads at about 500 megabytes per second, so the bandwidth of reading from a flash disk is quite good. If you read things that are next to each other on the flash disk, it doesn't speed things up much. This is quite different from a magnetic disk, where reading sequential things makes a big difference. But on a flash disk, sequential reads and random reads are about the same speed in terms of bandwidth. And if you wanted to read 64K, which is the block size that we had for our magnetic disks, it takes about half a millisecond. So it's pretty fast. Write, on the other hand, is not fast. It's slower for random writes than sequential writes also. So that's a thing where writes are more like magnetic disks in a couple ways. They're slow, and there's a difference between random and sequential performance. So a single write, the latency is pretty quick. It's 0.03 milliseconds. If you're doing random writes of these small pages, like 4K, you can only get like 120 megabytes per second of bandwidth. But if you write things sequentially, if you write a file from block 1 to block 2 to block 3 to block 4 in sequential order, you can get about 4 times that bandwidth. Okay? So the difference is not as stark as it was with magnetic disks because there's no seek time. But be aware that write costs on flash are different for random and sequential I/O. All right? And this is one reason why using models for magnetic disks, which took into account things like seek time, still have some appropriateness even in the era of flash, because random versus sequential I/O matters on both media. Now, is flash faster than disk? Well, of course. It's called flash for a reason. It's fast. It can be somewhere up to about 10 times the bandwidth of an ideal hard disk. And don't forget, an ideal hard disk is probably not ideal. When you look at the specs for a hard disk drive online and you look at the manufacturer's spec sheet, they're giving you a very optimistic view of how much bandwidth they can do. And so you can expect for ideal bandwidth to get like 10x performance benefit from using flash over disk. But in practice, if you have non-sequential reads, if your reads are random and they bounce all over, you can get somewhere between 10 and 100 times the bandwidth on a flash disk that you would get on a magnetic disk. So somewhere between 10 and 100x for random IOs, speed improvement out of flash. That's a big deal. Now, the thing is that locality, this notion that things are next to each other or not, things being sequential, it matters for both flash and hard disks. So reading and writing to faraway blocks on a magnetic disk requires that slow seek and rotation delay. And as we said, for flash, writing to faraway blocks on SSD can also require these expensive writes because of write amplification. If you write 4K to one place and 4K to another place, that's actually maybe two very large writes that you didn't mean to have because of write amplification. Now, flash drives are increasingly getting better at this, so they're optimizing, and I think over time we might see that the random cost of flash keeps getting lower and more like the sequential write cost for flash, but be aware that right now locality matters for both flash and magnetic disk. And then with all this, we've been talking about speed, but don't forget that disk offers about 10 times the capacity of flash per dollar.